Hello and welcome. Today we'll be looking at domain and range of parent functions, and specifically we'll look at linear, quadratic, and exponential. So just take a look at the first example. We're talking about a linear function. In this case, it is a rising function. Okay, it's a rising line, which means the slope is going to be positive. What's the equation of this line? In function notation, y equals x, f of x equals x. Now, what is the coefficient of x? Just to remind you of the slope-intercept form, where m is the rise over run, which is the slope. In this case, it's 1x. So therefore, your slope is 1 over 1, rise over run. Let's take a look. Go to the y-intercept and go 1 up, 1 to the side. Always check the interval to notice. Okay, look at that. They double up on us. So that means this is 1 and 1 to the side. 1, 1, 1, 1. Okay, works out. 1x it is. Let's look at the actual domain. Now, when we're talking about the domain, we're looking at all of the input values. Okay, we're starting at negative infinity and we are moving along the x-axis. The question is, what x values will produce an output? Okay, so in this case, your line goes on forever into infinity both ways. And we're pretending to start in negative infinity somewhere, right? And now scan left and right. You're always scanning left and right. You're on the x-axis right now, okay, choosing input. Now I'm looking to the side and so happens I can see. Okay, right there, my input for x produces an output for y. Now notice that obviously all points on the line are represented then by coordinates, x comma y. So that's when you're talking input-output. Each x value will have one partner as a y value, x comma y. Okay, so now I'm getting to the origin. And now my view will shift to the left. Boom. And I still see something. I see something all the time, okay? No matter where I'm at for x, I see something all the time. Therefore, my x values can be anything and everything I want. Here's what you can't do. Okay, let me show you what you can't do. You cannot say this, because when you are working with infinity, you're not going to include infinity since it goes on forever. Okay, so now let's look at the y. The range is dealing with the y. Okay, we're going to find an inequality to say that. Now, I just pretend basically to be stuck to the axis. Now, I'm looking at the output, okay? From the negative infinity, I scan, left and right, left and right, left and right. This is my y-axis. And now, do I see anything? Oh yeah, there it is, look. Ding, ding, ding. I see something all the time. Shift the view to the right, left and right, I check. Yep. So that means I don't have to exclude any y values at all. Y can be anything I want. Boom. And that is the domain and range of all rising and falling lines, as long as they're not restricted. All continuous rising / falling lines have this domain and range. This one. Always true. Now, of course, if you cut a piece of the function, let's say you cut it off like this, well, that will change your domain and range. You can play with that later as you please. Let's look at quadratic functions this time. Now, what is the graph of a quadratic function? It's a parabola. Okay, not a line. It's not a straight line. It's a parabola. So it's curved, U-shaped. Let's take a look. We want to look at the domain. So that's your x values that are acceptable, meaning they don't need to be excluded, and you scan. Now, remember, your vision goes on forever. You look to the right, there's nothing. Okay, forget that. Now you look to the left. Oh, wait a minute. That's to be extended. Okay, so the actual arrow indicates extension. So therefore, I will see something. This input 8 will produce some sort of output, and exactly 1 actually. So that makes it a function in addition. So here we go. And all the time I find something going on, which means x can be indeed anything I want it to be. I like that. Makes it easy. Boom. Now let's look at your y values. Okay, shift your view. I'm gonna go purple. From negative infinity, ding, 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 going on. Okay, this was my x-axis. Now this is my y-axis. So I'm stuck to the y-axis. I'm checking. Okay, check to the left, nothing. To the right, nothing, 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 nothing. There's just nothing going on. I'm single here. Okay, I don't have anybody. Nothing going on up until a dream comes true when I meet somebody. There it is. My y value, the very first one, it's going to be 0. Now, did I meet 0 or not? Yes, I did. I ran into 0. So I'm going to include that. And then I'll continue. Okay. Oh, wow. Look at that. Now all of a sudden I have left and right. I can see something going on. So that means there will be values produced of some sort right here. Okay. I have 2 different x values actually that produce the same output. Not a problem, still a function. It does pass the vertical line test and all the good stuff. Now, is that true for all quadratic functions? This way? Well, you have to think about that. I'm not going to tell you. Yes, I will. Is it true for all quadratic functions this way? Well, think about it. Quadratic functions, what do they look like? Okay, so let's just state the parent function. We're going to state the parent function of this particular graph. This is x squared, okay? F of x equals x squared, function notation. What's the coefficient of x? Still 1. It's like invisible, right? But remember, if it was 0, what would happen? X squared wouldn't even be there because 0 times that would be just nothing. Can't do. But what's behind x? That's like plus 0. Oh, okay, that explains this. Stuck to the y-axis. That vertex, that is. Okay, so what would happen if I had a parabola like this? Oh, okay, wait a minute. That would be something like this. Would that still have the same domain and the range? Well, the domain would be the same, but the range would change. You tell me what it would be like. Yeah, it would stop at 0. Now, looking at the notation of the range one more time, just in case you wonder if you could have written it differently. The original range we talked about, yes, you can write it like this, and that's okay. All right, now for the black parabola, your range would start at negative infinity, people. Okay, so y would be greater than negative infinity, but less than or equal to 0. Which of course you can also write like this, and that's fine too. Okay, that's much for quadratic. And yes, those are functions. Here, exponential function. Where do we see that? Yeah, like bacterial growth, stuff like that. So let's see. This one is tough. Why? Because it's a little bit of a weirdo. Let me tell you why. Let me select black again. Here we go. It was already selected. So it goes into infinity just like the other two. It's not restricted, it is continuous. So now what's going on? This is the most important thing about horizontal, about the exponential functions, the horizontal asymptote. Now, horizontal, hopefully we know, is this way, okay? Think of the horizon. So here's your sunset, going down. That's the horizon. Therefore, horizontal is a line from left to right. So here we go. What are we talking about? The horizontal asymptote will be, in this case, your x-axis. Okay, what's the equation of the x-axis? Come on now. What's the equation of the x-axis? The equation of the x-axis is y equals 0. For this particular example, okay, and you may wonder what that example actually is. What is it? Nobody knows. Yeah, maybe you know. 2 to the power of x. And why is that? Because exponential functions look like this. And you may say, well, wait a minute. So what about the y-intercept? That's actually 1, 0, 0, 1. What is it? How about 0 for x, 1 for y? 0, 1. But this is a 2. How come? Well, that's the tricky part as well. It's actually 1 times 2 to the power of x. And the 1 is your a, and the a is your y-intercept. Okay, now you can figure out the 2 part and so on. That's like when something doubles, but that's not the point. The point right now is to understand the horizontal asymptote, because that's what determines how you're going to express your domain, range, whatever. So which one is impacted actually? This is what's going to be affected by this horizontal asymptote idea. Okay, let's look at the domain. Clearly x could be anything. Okay, so once again, x is anything. X is greater than negative infinity, less than infinity. Now for the domain. No, for the range. For the range, we're going on the y-axis. Ding, 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 ding. Scan, 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 left and right, left and right, left and right. Nothing happens, okay? So nothing happens here, okay, up until I get to which point? You tell me. Getting closer. Well, I got to the green line. Okay, the green line is my horizontal asymptote, people. Okay, right here. This is my horizontal asymptote. And what that means is that's the do not touch or cross situation. Okay, the horizontal asymptote is a line that the graph will approach, but never ever touch or cross. Even the calculator gets confused at times. So don't let that deter you from doing the right thing. What are we talking about? The range, guys, is going to start after 0. Okay, so the range is y is greater than, but not equal to 0. If you say equals, guys, okay, let me show you what not to do. Do not do that. Because if you say y can be 0, then you don't understand the idea of the horizontal asymptote. And that cannot happen. All exponential functions will have a horizontal, an amount of space. They'll have a horizontal asymptote, okay? And you have to remember that, because that will be what determines your range. Okay. Now, special cases. Let's just look at linear relations versus functions right quick, and then the domain and range of those two. So on the left side, I have a green line. Well, on the right side, I have a green line too. So right here is what I'm talking about. We have a horizontal line. Okay, so I'm going to show you right quick how to remember all the important things about horizontal lines. H for horizontal. Okay, we know that. The O right here for zero slope. And the Y for y equals some number. Now, in this particular example, since it crosses the y-axis at -4, it's going to be y plus -4. Okay, this is your x-axis, and this is your y-axis there. Okay, so that much for horizontal. Question is it a function or not? So here's what we're going to do. We're going to scan. Okay, let's scan it from left to right, and here we go. Ding, 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 ding. How many times do I cross, okay, the actual function? So think of the vertical line test. So one beam at a time. I'm crossing one time right here. Anywhere I perform the vertical line test, the line, the green line and the vertical line will get in touch with each other at one particular spot. That's it. Never twice, never 3 times, never more than once. That makes it a function. Okay? So the horizontal line is a function. Okay? All horizontal lines are functions. Not just relations, but functions. What about vertical lines? Okay, perform the same test here. Well, let me pick a different color. We're going to perform the same vertical line test here. What happens, people? Oh, wow, I couldn't fail any more often than that. Okay, so it fails the vertical line test infinitely many times. Okay, so here, fails vertical line test. And that's what makes it a relation, not a function. Now, I have to tell you, this is a relation as well, but in addition, it's a function. It's like a square that's also a rectangle at the same time, right? But not vice versa. So now let's look at another way to remember the vertical situation, VUX. V for vertical, U for what you're not going to do, and that is forget that the slope of a vertical line is undefined. And you may wonder why. Quick explanation: undefined because rise over run. Run would be 0. Like if you're within the line, you can run, but you can't. You can rise, but you can't run. You can't make a sideways movement, so your sideways movement would be 0. Rise over run would end up being 0 down here. Division by 0 cannot happen, and therefore undefined. And then x would be your actual equation of the line. So where did this line cross my x-axis? That's the question. Let's look. Where did it? Looks like it was at 2. So the equation of this line would be x equals 2. Easy, right? Now, we want to know the domain and range of each of these. Let's state it right quick, and then you'll be done. Okay. Think again here. This is your x, input, x-axis, okay? Starting at -infinity, scan. Ding, 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 ding. What's happening? I'm looking to the left and right. Oh, here is a function. Oh, yeah, here. So I'm going to find an output for any x value, correct? So therefore, my domain is anything I want it to be. Okay, all real numbers. Let's now look at the range. Boom. We are down here on the y-axis, left and right, left and right. Oh, wait a minute. Nothing, left and right, nothing. There we go. I ran into some sort of value, and then there's a lot. And then there's nothing again, like nothing at all. So that means my range consists of exactly one y value, okay? And who's the lucky winner? Is 4, -4. So here's how you do it. You can put it in brackets if you want to. That's your range. Nothing else you can do. Why? Because this is the only value at -4 that produces anything, input-output wise. Okay, let's look at the final one, which is the vertical, which is also like an exceptional case when it comes to domain and range. Back to your x. Okay, let's look at your x values, input. Is there anything going on left and right? Nothing. Nothing. No matter how far I look, there will be nothing up until this happens. And it goes through 2 in this case, and then nothing happens again, ever again. So therefore, my domain, people, is x is 2. Positive. Check that it's positive or negative. Yep, positive 2. And that's all there is. Yeah, this one did fail the vertical line test. It's not even a function, but it doesn't mean you can't determine domain and range. Now the range, I'm starting in negative infinity. The function goes on forever. And yes, I can see something all the time, no matter what I do, where I go. So the range could be anything. Okay, my range is y is anything I want it to be. All real numbers. Boom. Okay, this is how you can say that. And then here for the range, you could have said R. All real numbers. From me to you. Have a good day.